All right, good morning, guys. We got 5.1 mid-segment theorem and coordinate proof. Like always, we have the objective in the middle. At any point during this video, if you need to pause, go ahead and do so you can get caught up. But I'm going to keep the pace rolling here. All right, so for your notes, I would put on the right-hand side of your notes the mid-segment of a triangle. So I'd put this first sentence right here. Is a segment that connects the midpoints of the two sides of the triangle. All right, so it's the very first sentence, and it ends right there. Now, I want you guys actually to pause and watch this for a sec. If I make a triangle, here's what they're talking about when they say mid-segments, guys. If I make a triangle, the mid of the segment, the mid-segment is in the middle. So if I draw a dot like right here, that's in the middle of that segment. So I could put singles on both sides because those two are the same. I would find the middle of this segment. I could put doubles on that because those two are the same. Same thing with the last one. I could put triples on there because those two are the same. The mid segments is when you connect those dots then. There we go. And I'll explain more in a little bit, but for right now, I would put this diagram in to go with this first sentence right here, guys. All right, now that we have that, also with a mid-segment theorem, there are a couple things that we need to know. First, you see the arrowheads on here that these two lines are parallel. Now that's true with a couple of those lines on a mid-segment, but you should be able to tell that the long side, for example on this one on the bottom, with the mid-segment in the middle, those are parallel. Also with this problem, you can see that the shorter segment is exactly half as much as the longer segment, which is this part right here. Okay, so this is telling you that they are parallel. This other part is telling you that one is half the size of the other one, or if you take the shorter side times 2, that would equal the length of the longer one. So go ahead and take the time to please put this diagram right here into your notes. All right, this one does not go into your notes. This part that students struggle with the most is there's so much that seems to be going on in these problems. But if you just take it one step at a time here, now without even reading the directions, if I just focus on this bottom part of the triangle here, this one right here, I know that's 90. Now if I look up for another parallel line to that, I'll look up right here. See how that one is parallel to it? That would be the mid-segment that would go with it. And it's always half as much. So for example, if I were to find UV, it would be half of 90, or in other words, 45. And that is one of the answers that they want us to find here, is that UV equals 45. Now if I continue on, I'll highlight the segment of 57 that they have right here. Now we want to look for a segment that's parallel to that, and then since we were in the middle of this big triangle here, we'll go out here. We see how those two are parallel. Now 57 is half the size of that longer one there, so just take 57 times 2, or 114, and that would be the distance from S to R. All right, guys, so I would put these in your notes right here. We want to place each figure in a coordinate plane in a way that's convenient for finding the side lengths. When they say convenient, you're always going to start at 0, 0. Now we're going to assign coordinates, and this is the part that's a little tricky. First thing, we want to just make sure that we have a coordinate, and then, of course, this is our origin, or 0, 0. And if we're going to make a rectangle, why not make it as easy as possible? So I'll put a dot here, here, and here. So I have my rectangle. And they want us to write down where the coordinates are. And of course, this one is 0, 0. All right, that's the easy one. Now here's what's going to seem a little strange right away. If I'm looking at this coordinate right, I'll draw an arrow here, that one right there. I know that I had a shift to the right. Now, how much is it? Well, I'm not going to put a number value on it, but I'll put a letter because I don't know what it is. So I'll put like, let's say this right here is x, and I went up and down 0, right? So this coordinate would be x, 0. Okay, now I'm looking at this coordinate over here. If I wanted to give that one a coordinate, I know that I had to move up, but I didn't move left or right at all. Now, I moved up a different distance than what I did to the side, so I'll use a different letter rather than x. I'll use something like, let's go with 0, because I did not move left or right, but I did go up, so I'll use y. And you could use any letter you want. I believe the book uses different letters than what I did. Now to get to this last coordinate here, not only do I have to go over, but I also have to go up. I know how much I went over. I went x, and then I went up the distance of y, so I have my coordinate xy. On a scalene triangle, you want to make it as easy as possible, so I'll have one point at 0, 0, and scalene just means everything's just a little bit different. I'd put another dot located on this line, and then as long as you don't put it dead center, it should be scalene, so just put it off to the side, making it a little bit easier. Connect the 3 dots. The easy one is at 0, 0. I'm going to go forward a distance. It doesn't matter what letter you use. Let me switch it up. Let's use the letter K this time. I'll go forward K, but I'm going up and down 0. All right. Now here's something that's a little different. This spot right here is forward a distance and then up a distance. But it's not the letter K. I mean, we already have that over here. So we need to make up 2 brand new letters, and let's just make up the letters. Let's go with A and B. We went forward the distance of A. We went up the distance of B. We don't know what they are, so we can assign them any letter we want. Place a isosceles right triangle on a coordinate plane. So I got my 0, 0 right there. When I think of isosceles, I think I want to go out the same distance. So if I go out this distance, I want to go up a distance very, very similar, where I could put tick marks on, and I know that's an isosceles. That's a bad isosceles triangle. But you get the idea. These are supposed to be the exact same. Okay, so I'll list its coordinates. This coordinate is located at 0, 0. All right, this next one here, I went forward, but up and down 0, so I'll go x, 0. You can use any letter you want. This next one over here. Now, here's what's different. It's isosceles, so I'm supposed to go out x. So that means I'm supposed to go up the distance of x. So left and right, 0, but up x. Okay, so let's talk about the next thing they want. Then find the length of the hypotenuse. The hypotenuse is right here. And length means I want to find distance. So I'll use the distance formula to do that. And hopefully I don't run out of room. The distance formula is x2 minus x1, parentheses squared plus. All right, then the next part. Now, it doesn't matter what you use as your x2 or your x1 as long as you're consistent. So we'll call this the x1, y1. We'll call this one over here your x2, y2. Like I said, it makes no difference whatsoever. So if I use these numbers, I'd be taking 0, subtract a negative x. Gotta fix that. Make sure I have that right. I would be taking 0, subtract x. There we go. Plus. My y2 in this case is x, subtract 0. Okay. All right, so then we want to break it down from there. If we take 0, subtract x squared, we'd have 2 negatives, which would turn to a positive. So we'd have x squared plus x subtract 0 is still x. X squared. 1x squared plus 1x squared would equal 2x squared. Okay. Now the midpoint. Oh, I did have to put square root around it, guys. There we go. Square root. Square root. There we go. Yep, there it is. I just forgot to bring that down. All right. Now the midpoint. What we want to do is we want to find the middle of the hypotenuse. Let's see if I can point out a little bit. So right there, guys. We want to find the exact middle. And if I told you to find the middle of two numbers, hopefully you think you'd find the average, or you'd add them up and you'd divide by 2. So that's exactly what I'm going to do. I'm going to add up my x's and then divide by 2. So let's say 0, I'm grabbing this number here, plus x, 0 plus x divide by 2, comma. Now I'll find my y coordinate. I have another x plus 0, x plus 0 divide by 2. If I take 0 plus x, you'd still get x. So x over 2 would be your coordinate. And the same thing over here, x over 2 would be your coordinate, which would be located right there. And we're not doing this one. And here's the last one, guys. Now, this is directly from your homework. So if you want to write this down, you're more than welcome to. It is one of the problems you're assigned. They're telling you that AC, which is 3y minus 5, and HJ, which is 4y plus 2. So here's where I would ask you guys, what's the relationship between the two blue lines? And hopefully someone would be thinking about, well, the shorter one is half the distance of the bigger one. Or you could say if you take the shorter side times 2, it equals the bigger one, right? So that's exactly what I'm going to do. I'm going to take whatever this was, AC, and I'm going to times it by 2. So 2 times 3y minus 5 equals 4y plus 2. All right, and I took the shorter one times 2 because that would equal the larger one. Distributive property here. Now I got y equals 6. But what's interesting about this problem is we got to make sure we write down what they need. So they want us to find out what HB is, which is the distance from here to here. Okay. Now, HB is the same as AC. Those two are identical. So if we knew what AC was, we could find out what HB is. So what I'll do is I'll use the equation for AC, which is right here, and I'll plug 6 in place of the y value right there. So 6 times 3 would give you 18, minus 5 would give you 13, guys. So the distance from A to C and H to B would be 13. All right, guys, so that's it. Hopefully everything goes well for you today. If you didn't understand something, you could always rewatch the video. That's not a problem. And if you still have additional questions, come and see me in the morning, but make sure you give each one a try so when you come in for help, I can ask you what you tried. And that should be it. Have a great day, everyone.